For number 5, well, there's 0, there's -1. Oh. I'm looking only at the x's for domain, and it starts right there at -1. And it goes forever. So x has to be greater than or equal to -1. Everyone good with the first page? Going once. Going twice. Going thrice. Spectacular. Why did I have to list them? Because they're dots. It's not a line. There is no space of the x-axis that is filled up. It is only those dots. What does my first number here have to be? Will it be positive 1, 2, 3, 4, 5 because I started at -5? No. It will be -5 because lowest number first. They are not pairs anymore. Is it a function? Yes. Why? No same numbers. Straight lines only hit a dot once. If there was another dot there, is it a function? No. Relation. Why is this a less than and not an equal to? Open dot. -5, comma 0, round bracket. Does that round dot affect the range? Does it? Range is only the y value, right? So I don't hit there, but is there still a y value there? So does that affect the range? No, because the range goes from down here all the way up to there. Even though it doesn't hit this dot, it does hit y equals 1 right there. Does everybody understand that? Everybody? So the range is -1 y less than or equal to 1, 2, 3, 4. Does everybody understand that? Because there was that, the value of 1 on the y-axis exists right here, doesn't it? At -1, 2, 3, 4, -4, 1. That exists. But 0, 1, this one doesn't exist because that was the open dot. Everybody cool? Nathan. Because this dot was an open dot, remember? I told you that yesterday. Number 3. X is less than or equal to 6. Or, round bracket, -infinity, 6, square bracket. Union with y equals 4. Or -2, 1, union 4. Does everybody understand why that one is? I'm sorry, what? It goes all the way to negative infinity. Which dot? This one? They're all closed. Heather. No, you need to be able to use both forms. I told the class to use brackets on the first one and arrows on the second one. But halfway through the work, people are like, which do we use where? So I'm just showing you both. Pardon? You understand this part? Goes from negative 2 up to 1, right? But then there's another y value, right? So I have to have a union. Tajvir. Of course you can, Tajvir. Domain. X is a set of real numbers. Y. You can plainly see there's open dots. Jacqueline. If there's, yes, if when you are looking at your axis, you have more than one spot that's colored in, you have to use a union. Now this one always messes kids up because I say it's every single number ever. And they're like, what? Why? I can see there's open dots. It can't be. But there is. Why, Rylan? There's arrows going both ways, and that dot doesn't exist, but does that one? So x is 1, 2, 3. X is negative 4 doesn't exist there, but it exists there. X negative 1 doesn't exist there, but it exists there. X to the 3 doesn't exist there, but it exists there. Because we are not looking at both, we are only looking at the x's now, yes? And you can quite plainly see that all of these x's exist with arrows on the ends. Okay? Range is negative 3, 0, 3, 4. Why? Because I only have y values at those 4 points. It is not a portion of the y-axis. Yes, Heather?
So what does XER stand for?
X means X is all the real numbers. Because every single number can be put there. 1.739. Square root of 2. Right? All of them exist. 5. Domain. Negative 1 less than or equal to X less than 1. 1, and range, negative 3, less than or equal to y, 1, 2, 3, 4, 5, 6, less than or equal to 6, negative 3, nope, not less than or equal to 6, you idiot, 6, round bracket. And lastly, everyone's like, what? Yeah, you just count where it fills. Negative 5 to positive 5. And negative 5 less than or equal to y, less than or equal to 5. Negative 5, 5. Can everybody do domain and range? All you got to do is remember which is which. Domains live on the x, ranges live on the y. Okay? One sec, Nathan. Is that always the case? Is that something you should stick in your mind, that domains live on the x all the time? No, because the domain isn't x. The domain is the independent variable. And if the graph is turned, like remember the heights of the dog? If I turn that graph sideways, the independent variable is still the dog's. Most of the time. And if it's ever just a graph like this without any telling you, without a title, the domain is the x's. Everybody cool? What's the one thing that we often count that is 99% of the time the independent variable? Time. Is your hand up? What? Because they're dots. We didn't color any part of the axis. Yeah. Nathan, you had your hand up before all that started. What?
I understand like the union that it's like because there's two of this thing on the same axis.
Yep.
Totally understand what it means. I don't think we were talking about that.
Sure we have. Pretend that's not there. What's the range? This part, right? Okay. The range is all the y values, yes? Okay. But if that line's there, isn't there another y value right there? So, I have one set of range and another set of range. So they have to be union because they're on the same graph. Yeah. 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 If this had gone this way, then there would be another set of brackets over here. Everybody cool? Okay, turn the page over. Let's do some reading of graphs. The first 6 questions on here, 1, 2, 3, 4, 5, 6, you can already do by reading the graph. In this white space over here is where I'm going to teach you some math. So the first thing you need to do is answer all these questions. The third one might cause you a bit of issue, but I bet you can figure it out. Go. You can talk to each other. It's not a test.
Is it ever possible to do independent variables?
No, of course not.
Well, like, how does the time and depth depend on
If you don't get it, you're going to want to listen to the explanation, right? Are we ready to go yet? I see a lot of pencils still moving, so I trust we are not quite ready to go. Okay. What's the IV? What's the DV? Time is the independent variable. The depth is the dependent variable. Who can tell me?
Sorry for the interruption. Could I get any grade 12s that have not written the satisfaction survey to please come to the computer lab now, the library computer lab? So that's any grade 12s that have not taken this satisfaction survey. Thank you.
Why? Time always goes on. As time passes, if I am a scuba diver, obviously I am diving. The longer I'm in the water, the further down I can go. You people up on the boat, are you getting any deeper in the water? No, you're on the boat. Everybody cool? Now the next thing I want to say to that is this very important piece of information. Is this a graph or is it a picture of what is happening in real life? Okay, so if it's a picture of what's happening in real life, let's draw it. There's the water. There's the boat. And here's the scuba diver. If that is a picture of what is happening in real life, as time goes on, that scuba diver goes up. Really? Scuba divers fly?
No.
Where do they go? Under the water. So you need to remember that a graph represents data all the time. It does not always draw what is happening in real life. Does everybody understand that? Okay, good. Next, how long did the dive last? 30 minutes. How do you know it's 30 minutes? Every square is worth 2, right? And here I am at 0 depth. So obviously I am back at the surface. Right? You're not diving if you're not below the surface. Now, here's where it gets tricky. At what times did she stop her descent? Nathan. 4 to 8 and 13 to 13 to 10, thank you. 10 to 14. Then she starts her ascent, but she stops her descent only in those points. What lets you know that these are the right answers? Gap? I don't see a gap. It's a solid line. So what is it? What is it about this red graph that lets me know those are the right answers? Nathan.
Because it shows it that she's not going down anymore.
Exactly. That flat line means what is still passing? Time. But is the depth? No. So here is where she found Dory. Here is where she found Nemo. Get it? And once she's found Nemo, she's going back to the boat because what the hell else are you going to see under there? Everybody understand? The flat line means that. Now, let me ask you this. On a graph with time, could you ever see this line? No, because time can't stop. Everybody understand? On a graph, could you ever see this line? Why not? Time can't go backwards unless you have a nuclear-powered 1985 DeLorean with a flux capacitor. Thank you, Tajvir. You're on fire lately. Okay. What was the greatest depth? 20 meters. Easy peasy lemon squeezy. How long did she spend at this depth? 4 minutes. Because she hit 20 right there and went to there, yes? What is the domain and range? So, what is the domain, which we will do in blue? No. 0. Less than or equal to? No. Time. Less than or equal to? 30. Or 0, 30. What is the range? Depth. 20. 0, 20. Is everybody cool? Everybody's good? All right, now we got to learn some stuff about this graph. We're going to talk about this graph in 3 stages. There is going to be stage 1, which is light green. There is going to be stage 2, which is pink. And there is going to be stage 3, which is blue. That's a bad line. All right. Without writing anything down yet, in that green stage, describe to me in English what is happening. She is dropped off the boat and is swimming downwards, yes? Is time passing? Yes. Is she going through a distance? Yes. So she is going through a distance. Oh, I should do this in green. She is going through a distance over a period of time, correct? Have we seen that construction before? Sure we have. How many of you have driven your cars? How fast do you drive your car in the city? 50 km over 1 hour. A distance over a time, yes? And that 50 kilometers an hour is what we call a speed. But what it really is a rate, isn't it? And that rate says, for every hour, I will travel 50 kilometers. Therefore, if I drive for 3 hours, how far will I travel? 150 kilometers. If I have driven 500 kilometers, how long has it taken me to do so? 10 hours. We all understand this, yes? Now, you're intelligent young people. If this in time was speed of a car, what would we be measuring it in? Hours. And if this was distance a car travels, what would it be in? Kilometers. So kilometers divided by hours, right? Meters divided by minutes, right? So a rate is always the dV divided by the IV. Does everybody understand? Because it just happened twice in math, right? We took the distance, we divided it by the time. The distance was the dV, the time was the IV. Everybody cool? Great. So now, tell me how fast she swam downwards in this first section. 12 meters in what? 4 minutes. Do we agree? Would we ever give a rate like that? Do I say I drive 500 kilometers per 10 hours? What unit do we have? What number do we put on the bottom of a rate? 1. So I need this to be 1. So I divided that by 4. So it is 3 meters per minute. Does everybody understand? Everybody get it? I dropped 12 in 4 minutes. 12 divided by 4. Cool? Great. How fast did she swim downwards here? Eight. 2. So it's 8 over 2, which equals x over 1. And because that divides perfectly, we know it's 4 meters per minute. Agreed? Everybody cool? Okay. Now, I want you to notice something. Which rate is faster, pink or green? Pink. How would you describe these two lines if you were to compare the green and the pink? Pink is faster? A line can move fast? That line's not moving anywhere. Describe the line to me. Steeper. That's what I'm looking for. The steeper the line, the faster you're moving. Why? Because you're using more distance in less time. Does everybody understand? Excellent. Now what's the blue one? 20. 14. 20 over 14. Is that the way we do a rate? Of course not. What does it need to be? X over 1. Now, this doesn't divide perfectly anymore, does it? So I have to do algebra here. I want x by itself, right? Now, we could do all the long algebra, or we could remember that thing I taught you in the very first unit when you have fraction equals fraction. Anybody remember? Cross multiply. What's 20 times 1? 20. 14 times x? 14. So it's 20 divided by 14. The only reason it's not one you can do right in your head is because it doesn't do it perfectly. So I just use my calculator to do 20 by 14. And what is it? 1.43 meters per minute. Now you can quite plainly see that this is way less steep than these, yes? But let's talk for a moment. If you were to compare the green and the pink and the blue, what would you say about them other than steepness? They both, okay, but that all comes into steepness, doesn't it, Nathan? This uses this much, this used 1 square, and this used like 8 squares, right? Anything else? No, you're lawyer balling yourself. Don't talk to me about, I asked you to tell me about the lines. Don't think about gravity. Don't think about string theory. Talk to me about the green, pink, and blue lines. Describe the differences to me. We know that pink is the steepest. What else is different about green, blue, and pink? Okay, but let me ask you this. Couldn't this pink line carry on? And then it would end up taking up that much space, yes? Okay, so it's not that. Green and pink. Everyone agree? It leans from where to where? Left to right. What's the blue one do? Right to left. Why? Because one is getting bigger, so her depth is increasing, so it is becoming positive. Even though she's going underwater, the number is getting bigger, so it's positive, yes? What is happening in the blue line? The depth is getting smaller, so the number must be negative. So this rate would be what? Negative, because she is returning home. Does everybody understand? Excellent. Now, we are going to do the opposite thing here. Here is a graph. Write me a story. Is this English class? No. Am I going to give you extra grades for having an introduction? For having conflict? Person versus person, person versus himself, person versus environment. Am I going to give you extra points for having rising action? Am I going to give you extra points for a climax? Am I going to give you extra points for a denouement? No. I just want to know what happened here. Talk to your neighbor. Figure it out. Go. What really happened? I'm a good big brother. Yes, that's what big brothers do. All right. Now, let's talk. How do I know the watering can isn't all the way full? Riley. Because at 0 time, there's 1 liter in it, right? So what is happening from A to B? I am filling it. Over a series of time, the volume in the water goes up. How fast? 0.75 liters, right? In how many seconds? 30 seconds. Now, would we do that rate? What would be a better rate to use? I would use minute, which means 1 minute is how many 30 seconds? 2. So if I multiplied this by 2, what do I do that? By 2. So how quickly was I filling the water bottle? 1.5 liters per minute. Nice job, Malik. Everybody cool? What happened from B to C? It didn't. Well, according to the story, what did I do? No, I walked over to my sister because time passed, but no water left the watering can. Right? So here's my walking. Why? Time passed, no water spilt out. Right? Okay. Then what happened here? I dumped it. How fast? How? How much did I dump? 1.75 liters in 20 seconds. What would be the proper rate there? 1 minute. How much did I have to multiply this by to get to 1 minute, which is, of course, 60 seconds? Times 3. So what do I have to do here? Times 3. So what's the answer? $3.25? 5.25 liters per minute. And my poor little sister is soaked. Everybody got it? Ease peas lemon squeezy, right? Let's prove it, shall we? Turn the page over. Try. Now listen to me, please. I know some of you refuse to do this. But I am begging you. Attempt to draw this graph in pencil. You're gonna make a mistake. Okay? Go. So you need to decide on IV, DV. I taught you all that stuff. Why wouldn't you say it? All that stuff that I just said. Positive, negative. The only directions in math class. Hey, Nathan. There's 0, right? There's 0, right? What's the only directions numbers can go? Positive or negative. Doesn't matter where I turn that number line. Every number is either positive or negative. There is no sousaphone number. Right? Grrr. Okay. What's happening here? Again, how many parts are there to the graph? So how many points must your story have? 3. What happens in the gold line? That's her starting. What do we call that? Acceleration. This is not any distance traveled because we're measuring her speed. At the beginning of the race, is she moving? No. When they say ready, set, go, her job is to get the top speed as quickly as possible, yes? So the first thing she does is accelerates from 0 meters per second to what? 8 meters per second. Now, physics teachers will tell you they don't like to use the word accelerate and decelerate. They don't like that word. They like positive acceleration and negative acceleration. And I will leave it to Mr. Morrison and your physics teachers. What is happening here? No. I'm sorry, Sage, I can't hear you because other people are yapping. What?
You said from it goes 0 to 8, wouldn't it be because it's in 2 seconds?
Okay, now what you're describing, it took, now that's my next question. How long did it take her to get to top speed? 2 seconds. Okay, you're answering my next question. Okay? So, she accelerates from 0 to 8 meters per second, and now I'm going to say how long did it take? In 2 seconds. Right? Now, there's this line. What happens from A to B? She's going sideways. She maintains top speed of what? For how? 14 seconds. What happens at 14 seconds?
She slows down.
Why?
The reason about negative acceleration.
She crosses the finish line. Crosses line at 14 seconds and then does what? Slows down to what? Takes 2 seconds to slow to 0. Now, in English, we say decelerate. But in physics, that's negative acceleration. Okay? They're not the same thing. They're almost the same thing. But some physics teachers will, no. And I'll be like, so I decelerated. No, you did negative. Now, if Mr. Morrison or the last physics teacher at this school, who was one of my best friends, heard me giving this lecture, they'd be all mad. And they're right, because technically it's not deceleration. Technically it is indeed negative acceleration. But the explanation of why it is that is not for math class. It's for physics class. Okay? Okay. Your job is to attempt page 154. You're going to draw four graphs. That's your homework. Okay? What? No, just sketch it. Just like we did here. You didn't need graph paper, just sketch it. Okay? You've got 20 minutes in class to do those. Then you're going to want to look at page. Now, please, ladies and gentlemen, look. Page 155 and 156 and 157 look like a crap ton of work, don't they? Because it's 3 pages. But please notice, every question has a giant picture. So there really isn't that much work there, yeah? Some of it, as much as you feel you need to do. Okay?